Wow. This room is so intimidating. It really is. I mean, you got like the wings over here, and you've got the the nosebleed seats up there, and you've got, I guess, the VIP seats down here, and I feel like I owe you some kind of Broadway production, you know? But I already had one person over Twitter tell me not to sing. So I will not sing after this. All right. In case you're wondering, that's me. You don't care, though. Let's move on. The session is entitled Modern Web Architecture, and that's kind of an audacious title. That's definitely something that's designed to catch your attention, particularly because made up of those three terms, modern, web, and architecture, there's a lot we can definitely talk about. And part of what I want to do here is I want to go back and look at where we've come from. In many cases, it helps to know where you're going if you know where you've been, and in particular, what were the problems we were trying to solve back then, and more importantly, are they still relevant now? Because, quite frankly, it's very easy to get caught up in doing things because that's the way they've always been done. It reminds me of a story. It's a general story. It may or may not be true, but a young couple, man and woman, had just gotten married, and they were still in their honeymoon phase, right? Those of you who are married, you remember those days, right? When you would just sit and look at your spouse because, you were in love, right? You were too young to know any better. And one night, the husband was watching his wife prepare a beef roast for dinner. And as he's watching her cook, she slices off probably a couple centimeters of the meat on either side and throws the ends away. He's like, wait, what are you doing? She says, I always prepare my roast this way. He says, yes, but why? She says, it makes the roast taste better, and besides, my mother always did it that way. He's curious, so he calls her mother and says, when you cook a roast, do you always slice off the ends and throw away the ends? And she says, yes. And he says, why? And she says, well, it makes the roast taste better, and besides, that's the way my mother always did it. Well, her mother is still alive, so he calls Nana at the nursing home and says, Nana, when you create a roast, do you slice off the ends and throw them away? And she says, yes. And he says, why? And she says, because my pan is too small. That story works, by the way, when you're talking to management about why what they're doing is screwed up, but we'll talk about that later. It helps to know where we've been. It helps to know what we did back then and why, in order to be able to know whether or not what we're doing today makes sense. So let's start by talking about a little history here. The web has gone through many different technology iterations. And it's not so much the fundamental protocol that has changed. HTTP is no different now than it was 20 years ago. Right? There have been a couple of incremental additions, but for the most part, it's the same thing as from 20 years ago. But in fact, the web predates HTTP in a major way. Stage one of the web was a project called Xanadu. Xanadu was the brainchild of this computer visionary by the name of Ted Nelson. And Wired magazine did a complete story on Xanadu and Nelson and so forth, going all the way back through the history and the roots and so forth. And if you want to talk about a really audacious project, I mean, this guy envisioned a large part of what we now consider the World Wide Web, but he was looking at it back in 1960. All right, that's 55 years ago, assuming my math holds. And a word processor capable of storing multiple versions, displaying the differences between those versions, wanted to facilitate non-sequential writing in which the reader could choose his or her own path through an electronic document. In other words, he's already thinking. In 1960, he's already thinking about hypertext. A global hypertext publishing system, the longest running vaporware story in the history of the industry. It's been in development for more than 30 years. As a matter of fact, Xanadu finally reached a version 1 about 5, 6, 7 years ago, something like, and the 3 people who use it are already asking for version 2. It was meant to be a universal library, a worldwide hypertext publishing tool, a system to resolve copyright disputes, and a meritocratic forum for discussion and debate. Check this out. By putting all information within reach of all people, Xanadu was meant to eliminate scientific ignorance, cure political misunderstandings, and on the very hackerish assumption that global catastrophes are caused by ignorance, stupidity, and communication failures, Xanadu was supposed to save the world. I mean, you think you have it hard on your project. How many of you are writing software designed specifically to save the world? Show of hands. Must be the lights. I don't see any hands raised. Come on, save the world, right? Eliminate world hunger, create world peace, eliminate global catastrophes, make tsunamis go away by throwing spam at it. I don't know. Very, very, very audacious piece of software. But you can see already a lot of the bare bones, the skeleton, the framework that the web would ultimately turn into. There were 17 rules with respect to Xanadu. Many of these will seem pretty common sense today, but remember, 55 years ago, a lot of this was, all of this was really science fiction. Each server uniquely and securely identified, operated independently. Each user is uniquely and securely identified. Users can search, retrieve, create, and store documents, right? You're starting to get a sense of, okay, aside from the securely part of all of that, we've come pretty close. We've managed to do a number of these things, right? We can certainly identify servers uniquely. That's kind of what IP is for. And they can be operated independently or in a network, right? Wi-Fi off, Wi-Fi on, it all just works, right? Each document can consist of any number of parts, each of which may be of any data type. Well, we certainly have that with respect to HTML, right? You can have a page, it's got some text, it's got some graphics, it's got some more text, it's got a flash video, all kinds of different stuff we can put in there. Each document can contain links of any type, including virtual copies to any other document in the system accessible to its owner. This is a part where the web kind of doesn't meet up with what Xanadu's original intent was. Nelson had this vision that you could include, like slurp, what he called transclusions. You could slurp parts of that document in to be part of your own while retaining the original notion that it's coming from over there, even though you're reading it over here. Links are visible. Permission to a link is explicitly granted by the act of publication. Each document can contain a royalty mechanism at any desired degree of granularity to ensure payment on any portion accessed, including virtual copies. So check this out. You create a page on the web, and you decide that every time somebody links to your page, that's $100 in your pocket. I'm sorry, what would that be, like 3,000 zlotny? I don't know what the exchange rate is, right? That's money in your pocket just because somebody links to your site. Who's down for that? Oh, come on. You can't all be like idealists. Who's out here to actually make money? Yeah, okay, now we're starting to get, the rest of you are like, no, I don't want to be paid for my efforts. I work on open source. You also live in your mother's basement. Anyway, each document automatically moved to physical storage, stored redundantly, et cetera, et cetera, et cetera. You can see that Xanadu had a number of these ideas from the web baked into it from the beginning, right? But clearly, I mean, between 1960 and now, somewhere it took a really, really wild left turn, and a lot of that lies with its founder. The Wired article on Ted Nelson is great reading. It's amazing reading. The guy is a genius and a crackpot and an eccentric and an idiot and all these things rolled up together. He's everything you could ever want in an eccentric technologist. So it's a great read. From Xanadu, we got to Tim Berners-Lee, and we got to some of the very bare bones of what we now recognize as the web. We got to the basic browser architecture. Show me HTML. Give me a static HTML page. This was the era of the home page. You guys remember that? Some of you may not actually have been born when the home page was a big deal, right? If you're under the age of 20, the home page is actually older than you are, right? Netscape Navigator, I think, ships in 1993. So if you're under the age of 22, Navigator, now Firefox, is older than you are, which is kind of frightening when you stop to think about it. And we had a bunch of these pages that were out there, and they were all completely static HTML. There was really no level of interactivity here whatsoever. And we created a couple of things to try to make them a little bit more interactive, but not a whole lot. As a matter of fact, this may be something of an Americanism, but how many of you remember the movie Space Jam? Michael Jordan and all the Looney Tunes characters, right? That movie is like 20 some odd years old. Do y'all know that the website is still live? You want to step into the Wayback Machine for a second? Here, let me bring up a browser. Okay, brace yourself, folks, because this is not going to be pretty. Uh-oh. Got to move it over here. There you go. Welcome to the web, circa 1995. And I mean, it's everything that a good web page should be, right? Because we've got, like, if we click on some of these, we've got the press box. Where's another one? We got some good old frames going on there. Somewhere around here, we probably have like flames running. We got some clients. Oh yeah, there we go. There's the spinning GIF right there. Right? And let's see. There we go. We got the blinking frame over here. We're still waiting for this center frame to load. Right? Yeah, this was the web. This is what, depending upon your age, either you built stuff like this or your parents did. Okay? Now, if you are 35 or older, you built this shit. This is your fault. And the fact that you can still show your face in a public place is beyond me. Oops. Hey, come on back. There we go. The browser was useful. It had a bunch of interesting tricks and techniques to it. We were looking for ways to do things with it. This was kind of the time when we started looking for a little bit more interactivity. And so we said, you know what? We've got this really cool protocol called HTTP. Let's have it respond to things that come from the browser. So this became the era of like the hit count, where doing something on that page would lead to an HTTP request to the server to do something very, very trivial. Right? In many cases, this would like increment a number in a file, or would increment a value in a database, or what have you. And these scripts, this simple server interactivity, was often written using things like Perl or bash scripts, CGI bin scripts, etc. Because we didn't need a whole lot of interactivity here. We were just beginning to get our feet wet with respect to being able to do things on the server. We were still kind of figuring out what the right model to do that was, so we had a number of different approaches, right? Common gateway interface, and then the various web server manufacturers. They went off and created their own APIs because spinning up a shell and tearing it back down again was very expensive. And Perl, of course, was an interpreted language, and, well, Perl just sucks, period. Let's just call that spade a spade. And we got ISAPI and NSAPI, and we got several of these different C, C++ plugin technologies, because when you want to write something really reliable, that's what you want to do, is you want to write code where you have to manage pointers directly. Because now, if your plugin crashes, not only will it crash your code, but the entire web server with it. And that's good, right? Wait. Anyway, we moved on. That simple server was useful in a number of ways, but what we found is that HTML itself, particularly at this time frame, we're now moving into the late 90s, and there were a lot of companies, there were a lot of organizations that looked at a lot of the interactivity in the browser as dangerous, particularly JavaScript. There was a point in time, circa 1997 or so, where many US government agencies that were making use of the web, they explicitly required that the browser have JavaScript turned off because, quote unquote, JavaScript is a security hole. So if we can't do JavaScript in the browser, what do we do to get some level of interactivity? I don't want everything to have to turn into a round trip back and forth. So this is when we started looking at things to run inside the browser. This is where we got technologies like applets. We later got Flash, and then, of course, about 15 years too late, Microsoft said, ooh, Silverlight, we could do this too. The point is, at this point, the server remained pretty straightforward, pretty simple. The server basically is going to gather up a whole bunch of stuff, send it across as a part of one request, and then now you have your client. You'll interact with it. The client will periodically make HTTP requests back to the server, but it'll be basically a data type request. In a lot of cases, what we were doing is we were using HTTP as a gateway for something else. For example, for a long period of time in the late 90s, sort of the hip architecture was Java applet inside of a web browser talking to a Corba server who would then interact with your database and or other Corba objects back here behind the server. And that was considered cool beans. Problem was, it was too cool. As a matter of fact, by cool here I mean complex. Trying to get IIOP to run on top of HTTP and or open the necessary ports in the firewall, bleh. Let's just do it all on the server. So the browser went back to being simple, and this is when we got into things like servlets and JSPs and whatnot. We said we want to put all of that complexity in the server side. We want to do all of that in the server tier, the middleware tier, build up that HTML page, usually out of some kind of template, interspersed with model objects that we've used to gather data from the database, shoot that whole thing back to the client. The browser takes that HTML, interprets it, displays it. The user picks something, immediately request comes back to the server. The server takes that request apart, figures out what needs to happen next, generates the next page, and sends it back. This was, in many respects, the heyday of Java's server space. We have servlets, JSP, the whole Model 2 style. We later get struts. This is the era when Spring really comes of age. EJB starts to wind its way down. Spring starts to wind its way up, et cetera, et cetera, et cetera. Everything happening on the server. The problem is, and it wasn't just Java, by the way, you can see that there are a number of other technologies that followed the same path, choosing to change things up slightly as necessary. Ruby on Rails chose to do more configuration via convention rather than explicit configuration file. Some of these ideas we've taken, some of them we've left behind, et cetera, et cetera. PHP, of course, has been hanging out there for years, doing exactly this model, doing quite well. And of course, the whole model view controller thing emerged, et cetera, et cetera, et cetera. Thing of it is, this model suffers from some serious integration problems. If you've ever tried to look at an existing server, existing web server, right? There's a great website for doing travel reservations called kayak.com, K-A-Y-A-K.com. I don't know if it runs in Poland or not. But in the States, it's beautiful. You say, I want to go to Fort Wayne, Indiana. I want to go between these dates. And you can set sliders to say, hey, this is about how much I want to spend. This is about when I want to leave, et cetera. And it'll present you a range of options that allow you to choose which flights from all of the different websites that it's crawling. Where do they get that data? How do they obtain that data? For years, if you wanted to get data off of a website that didn't offer you some kind of explicit integration, the only thing you could do was like manually crawl the HTML yourself, pick it apart, parse it, somehow pick apart the HTML presentation bits and just get to the data bits. Ironically, during the early 2000 timeframe, when everybody was going batshit crazy over web services, SOAP and WSDL and all of that stuff, there was this idea that, yes, we want components that will just render data. That's what XML was kind of supposed to do in this vision, was just give us data, no presentation whatsoever, because then we wouldn't have to try to separate presentation from data. But that model took a really bad right turn when IBM and WebLogic and all those other really big vendors got a hold of it, and that ship sailed and then sank. But we still have this need to try to get at that data for a variety of different reasons. And so that's what's led to the current stage that we're at right now, where people are talking about building platform APIs, right? I want to create a way for you to consume the data that I choose to publish and use it in a variety of different ways that I may have never anticipated before now. I have no idea what you're going to do with this data, but it behooves me. It gives me some kind of competitive advantage, and/or it makes me the place that everybody wants to come if you come and get your data from me as opposed to from some of my competitors. Now, this is still very, very challenging for certain companies. As a matter of fact, recently, within the last couple of weeks in the US, there's been some court cases that have been going on about various websites that crawl the airline sites, gathering data and presenting it to their users. The airlines have been saying that their data is proprietary, it's theirs, and people crawling it off of their website are in effect stealing from the airlines, and therefore they want these guys shut down. And a judge just recently ruled that no, the data is out there in the open, anybody can look at it, therefore, if this guy has built a tool that aggregates that data and figures out how to get the best price possible, that's a perfectly legal use. This case is not done, but my point is, this is part of what we're struggling with today, how much data is too much and how little data is too little. We're still trying to find all of that. In the meantime, though, the world around all of this has changed significantly, and it has everything to do with these things, right? The internet is not just made up of servers and PCs anymore. We used to assume that. As a matter of fact, the big question back 20 years ago, 15 years ago, 10 years ago, the big question was, which browser are you running? Are you running Internet Explorer? Are you running Chrome? Are you running Firefox? Right? Safari within the last couple of years as the Mac has grown to gain prominence. But now, with the rise of the mobile devices, and it's not just devices in, the phablet form, right? These oversized phones. You've also still got people who are using smaller phones. You've got people who are using 7-inch tablets. You've got people who are using 10-inch tablets. As a matter of fact, wouldn't surprise me if at some point the MacBook Air kind of turns into a tablet. The Microsoft Surface already has. What's the difference between a tablet and a laptop if the screen is big enough? We've got a phenomenal number of devices out there that are all looking to interact with your data, with your system. And I don't want to have to build one set of endpoints specifically for iOS clients, and I don't want to have to build a different set of endpoints specifically for Android, and I don't want to have to build a third set of endpoints for the generic web, and I don't want to have to build a fourth set of endpoints for Windows Phone, all like 5 customers that use it. And we won't even talk about BlackBerries. Anybody, just out of curiosity, anybody in the audience actually have a BlackBerry? One hand, and you're very excited about it. You're holding on to that for the antique value? You're going to sell it on eBay in like 20 years or so? Look, kids, this actually was a company once. Excuse me. So if you've got this problem where you've got all these different things that want to access stuff on your servers, and you don't want to build all of these individual independent endpoints, what do? Well, HTTP from the get-go was designed to be a technology neutral protocol. It was designed to be very organic and very anarchic, and doesn't really care what you're running, doesn't really care what you're calling it from. So we started taking approach to, let me ship you my data over HTTP, kind of like the web services thing that we watched sail out into the ocean and die, but we're going to keep it really lightweight. We're going to keep it really simple. At first, we're going to do just XML, just plain old XML over HTTP. The problem with that is, a lot of times, the client receiving it has to be able to consume the XML, and a lot of times that client is the browser, and there aren't a whole lot of really good XML parsers in JavaScript, which is the ubiquitous client technology inside the browser. So then we said, well, is there a simpler data format we can use? And the answer, of course, was JSON. So that's where we are now. I will stand something up. I will tell you where the URL is. I will tell you what the JSON that I require coming in, or what the parameters should look like coming in, and I'll tell you what the JSON looks like going out, and we're done. You are now fully enabled to do this. Whether we call this a RESTful API or not, quite frankly, REST has kind of a religion around it that I just don't want to touch. Whether or not it fully follows the form of Roy Fielding's thesis, we can debate that, left and right, and people do on a regular basis. That's why I'm going to prefer to call them HTTP APIs. Quite frankly, I don't care if your API follows a RESTful pattern, the RESTful architectural style or not, as long as it works, and as long as it's consistent, as long as I understand what to consume and when. We still have a bunch of problems, though. First of all, the ubiquitous problem is link rot. One of the things that Fielding's thesis holds is that each document, each hypertext document, is state. And therefore, the document contains everything you need to know in order to move to the next part of whatever it is you're going to do. Hypertext as the engine of application state goes by the rather tragic acronym of HATE OAS. Hypertext as the engine of application state. And that works as long as every link inside that page goes somewhere meaningful. As soon as they don't, users start to distrust what we see on the web. And as a matter of fact, somebody, I don't know who, I read about this third hand, somebody conducted a study. They did like a Google search of the entire internet. I think Google may have sponsored this study. And they were looking specifically for all of the bad links on the internet. And I think the number came in at about 15%. 15% of all the hyperlinks that you will see across the web are bad. They will lead you to nowhere. And unfortunately, there's no way to correct for these. I mean, theoretically, the receiving server that got the bad link could go back to the client and say, hey, this is a bad link, right? That's what a 404 basically is. At which point, the client could go to the page that it just came from and notify the webmaster that they have a bad link. In the beginning days of the web, that was sort of the understood protocol to help prevent link rot. That died very quickly. Nowadays, what do we do about link rot? Pretty much nothing, right? Well, I mean, for your own site, that's really easy. You reboot the whole site and just, change all of your hyperlinks to whatever the particular scheme du jour is. But for all the people that were hyperlinked into your site, particularly if they were deep linked, they're just screwed. Too bad. You should be keeping up with the times anyway, man. The other thing that we've got, we have no integrated universal identity system. This is creating bigger and bigger and bigger problems for us today. And to see it, all you have to do, quite frankly, is go up to any CNN story, anything in the United States. I mean, if you want to, depending upon where your politics are, If you really want to see some of the worst of American society, go to the CNN story and read about the Charleston church shooting, where a white guy walked into a black church and shot up 9 people because he, quote, wanted to start a race war. Now, irrespective of the facts of the case, when you start looking at all of the comments on this page, you will see people saying some incredibly hateful things. And in many cases, they do so because it's not their real name posted there. It's a handle which they could create in 30 seconds. Or it's anonymous because the site allows for anonymous links or anonymous comments, etc. And if you've ever been on a mailing list and you get that one guy who's just annoying as hell, and you complain to the list moderator, and the moderator kicks that guy off the list, and next thing you know, he's back on the list under a different email, because Google will hand out emails to anybody who asks. They'll give them tens of thousands of them if they want. We have no way to be able to identify people, and even if you have a login on this site, it means nothing until you come to this site. We're trying to build some systems that will deal with this, right? We're trying to create things, OpenID, OAuth, et cetera, but those are still very much opt-in kinds of things. We have no redundancy. You stand up a server, well, that's the one server, unless you build it yourself or pay somebody else to do it for you. Now we can start talking about the various cloud vendors who are very happy to build in all the redundancy you want for, like, an exorbitant price. Excuse me. And bear in mind, by the way, everything we're talking about here for the web, everything is about hyperlinked documents. All of Fielding's thesis was about hyperlinked documents. It has nothing to do with anything else beyond hyperlinked documents. Fielding himself has stopped answering the question, but if you read a lot of his online commentary, he will tell you point blank, it is not REST unless you are using hypertext as the engine of application state. Do I really want to be shipping hypertext documents back and forth to everybody if I'm building World of Warcraft? Or if I'm building, what's the latest one from Blizzard, Heroes of the Storm? Do I really want to be shipping HTML back and forth to indicate that, yes, if you shoot this character, this is what happens? I mean, certain problems lend themselves well to hypertext, but a lot of problems don't. A lot of the state that we have to deal with does not lend itself well to hyperlinked documents. AKA, if you want to buy or sell anything, that's not really a hypertext document kind of story. That's not really a story at all. That's a business transaction. Which leads us to this really interesting conclusion that this web that we've woven is not just about HTML anymore. Because if you look at a lot of what we're doing, we're not shipping HTML back and forth anymore. We're actually shipping data. And it's not just HTTP, because now we're starting to see that HTTP is turning into a gateway drug for other protocols. WebSockets, right? HTTP built on top of TCP/IP, it's a great protocol, but it's specifically a request-response protocol. What if I want to do something that's bidirectional in nature, where the client doesn't always have to originate it? And in many respects, it's not just HTML plus HTTP. If we go back 20 years, that's really a true statement. The web is HTML plus HTTP. But today, I mean, is this HTML or is this HTTP? So what are we really trying to get to? When we talk about modern web architecture, what am I really trying to drive to? Well, specifically, there's 3 parts to that statement. Architecture, set of predetermined answers to the questions that developers will ask. That's really all that an architecture is. When a developer says to you, hey, what does your architecture look like? You need to be able to say, well, you do this, that, and the other thing, and that's how you work inside of this architecture. The web, let's just call the spade a spade right now. The web is not just about HTML anymore, right? As a matter of fact, there is a tremendous amount of things going on that do not involve a web browser at all. When I checked in for my flight here, I used the Fly Delta app on my phone, and that in turn was communicating with Delta servers. There were no web browsers anywhere involved as a part of this. HTTP was there, presumably to communicate the data back and forth, but there were no web browsers. Can you have the web without a web browser? Sure, we call it the internet. The internet is touching everything. It doesn't have to. We can certainly do things locally or at least offline in a networked fashion. But generally speaking, we want to do stuff over the internet because it's no fun playing alone by yourself anymore. Lastly, modern. And by modern, I mean it's not going to be legacy for at least a little while. We want to build something that's going to stand up for a while. And you know what? As much as everybody loves to beat up on these guys, COBOL programmers, tip your hat. Have respect for the COBOL programmers, because these people built code that didn't just last 5 years, it lasted 50 years. Just out of curiosity, how many of you are writing code today that you will expect will still be running in the year 2065? Show of hands. How many of you really want all of the code you're writing to be thrown away just as soon as you walk out the door? Right? These people were writing code that stood the test of time for a half century. I'll be happy if we can just get applications that can last for 10 years. What do I mean by modern web? Well, there's a number of fallacies around distributed systems. We should avoid all of these. We should avoid the fallacy that the network is reliable, meaning whatever we do, it should be able to support the idea that I can go offline for a while. This is one of the places where a lot of your web applications today, particularly if you're doing the complex server approach, as soon as you walk into a dead air zone, as soon as you go off of Wi-Fi, your browser is useless. You can't do anything anymore. Latency is zero, bandwidth is infinite, the network is secure. All of these are fallacies that software developers at one point or another have bought into. I have too. It's okay. We all go through this phase at some point in our career. And quite frankly, the sooner we recognize these as fallacies, the better off we'll be. But in some cases, you have to convince yourself that these are fallacies. There are still a bunch of people who will tell you that the transport cost is zero. It doesn't cost anything to move data back and forth across the network. Therefore, lazy loading in an object relational mapper is a perfectly good idea, because it doesn't cost me anything to go over the network, because transport cost is zero, and latency is zero, and bandwidth is infinite, and yeah. What do we want? We want something that's modifiable. We want something that's scalable, performable, reliable, composable, securable, interoperable, discoverable, internationalizable, because I stand here in Poland. Right? We want something that can be all of these things. Specifically, what we want to be building is platforms. We don't want to be building websites anymore. We don't want to be building web apps anymore. We want to be building platforms. We want to be doing what's called platform-oriented development. What does that mean? Computing platform, in the most general sense, a piece of software designed to run within, obeying its constraints, making use of its facilities. Typical platforms include operating systems and runtime libraries. This is a fairly low-level discussion, but resonates because we think about the JVM as a platform. It has a runtime system, it has associated libraries, we run code on top of it. Over on the .NET side of the world, we have the CLR, same basic story, that's a platform. PHP is a platform. Python is a platform. This makes a certain amount of sense. Set of subsystems and interfaces that form a common infrastructure on top of which a set of related products are developed. This is a little bit more generic. This is starting to get away from low-level components. And we start thinking about things like cloud, right? The Google Cloud Platform provides a set of services that you can build things on top of. Amazon, Azure, both of these provide these same sets of services, as well as, runtime components. It's a set of components, services, interfaces that are designed for developer consumption, built around a common infrastructure, designed specifically to be used by internal developers, external developers, or both, to create applications, tools, components of use to users. This is my definition. It's a little bit more complicated. The key thing there, though, is platforms are for developer consumption. You don't sell platforms to your grandmother. You don't sell platforms to people who are not developers. Developers then take those platforms and go off and build interesting things for those consumers, but platforms themselves are not something that end users buy. A couple other examples. Windows, of course, has been a platform for, 40 years now, if you stretch it all the way back to DOS. And they've changed the nature of their platform repeatedly. They started with C APIs, they moved to COM, they then moved to .NET. At one point, they flirted with Windows Runtime, WinRT. They've had a number of different APIs, different platforms. It's always technically been part of the same platform, because they've always been really good about trying to manage backwards compatibility. Salesforce.com is definitely a platform. Twitter is a platform. Twitter is a platform specifically for annoying the hell out of other people. Right? You can actually use Twitter to write messages, to ping people, respond to people, etc. They're all developer-based. Platforms are aimed at you guys, because we then take these tools and use them to build other things. Platforms are definitely not geared for for consumers. Now, in some cases, platforms will stretch across platforms, or they'll stretch across some various technology boundary. So, for example, Salesforce.com does not care what your client is. They will run on iOS, Android, Mac, Linux, Windows, whatever you'd like. Because again, they're built specifically to be something that reaches across all of those different platforms. Fundamentally, enough theory, a platform, communication backplane, we need to know how to talk to one another. Set of common entities, data types, one or more data storage environments, a shared execution context, some kind of versioning strategy, usually some shared security context, some level of data reporting and visualizing tools, and then additional stuff. Here's where I'm going with this. The next time your boss comes to you and says, hey, we need to build something new for the users, you want to build a platform. You don't want to just build an app. Reason being, quite frankly, is that this will enable extensibility in a way that your boss just won't be able to understand because he's not a developer. Now, in some cases, you will build both the platform and the tools that sit on top of it. We used to call this the middleware architecture kind of thing, right? You built the middleware, servlets, EJBs, etc. As a matter of fact, if a Sun guy from 20 years ago are standing here on the stage, they're going to agree to a lot of this. They're going to say that platform is Java EE, right? Java 2 Enterprise Edition, as we called it back then. And they're going to say the communication backplane is RMI. And they're going to say the data storage will, of course, be a relational database, but really what they mean is entity beans, because back in the early days of the Java EE spec, entity beans could store to either relational or non-relational databases, right? And the security context would be managed by Java EE, etc. Microsoft guy comes onto the stage, he's going to make the same argument about .NET. Talk to the Ruby and Rails guys, they're going to talk very similar kinds of things. All of these different platforms, they all follow some of the same basic scaffolding. And for most of them, they're going to choose HTTP as the communication backplane. That's fine. That works. HTTP is very, very widely interoperable. If that's what you need, a high degree of interoperability, then cool. HTTP is your huckleberry. Off you go. But in some cases, we need something that's got characteristics that HTTP doesn't support. Like, for example, I need to be able to do some form of broadcast. Right? I need to be able to take one message and push it out to a large number of clients. HTTP does not do that well. This is where some other form of communication backplane becomes helpful, a la messaging, pub sub, mule, camel, any of these various technologies, RabbitMQ, etc., that allow me to take one message and push it out to a variety of different clients. The set of data types and entities. At the end of the day, a platform is built around some particular concept. If you look at Facebook, Facebook is built around users. It's built around you. It's built around what you're doing today. It's built around what you're saying to people, your comments, your friends, etc. Those data types are very well understood, well defined by Facebook. And if you disagree with their data types, too bad, man. You're on Facebook. You have to do what Zuckerberg says you're going to do, because particularly if you're over the age of 30, you can't be trusted anyway. When you're working with a platform, the platform will typically define some kind of data entity that you are interested in, that you are working to consume. Now, one of the things that will frequently come up is it just a set of web APIs? No, because again, it doesn't have to be HTTP. But yes, from the standpoint that these are things that developers consume. And what developers consume are programming endpoints. Right? We want to work with something higher level than just passing strings back and forth. We like APIs, whether they're APIs from within the programming language we work with, or whether they're APIs defined over the web, or whether they're messaging endpoints. We start getting into the whole enterprise service bus story here, where we can define endpoints. A message comes in, looks like this. Yep, that's the code that we trigger that goes over here. Those APIs can take lots of different forms. They're definitely endpoints of some form. They're designed for developer consumption, but they don't have to be defined in any one particular language. That's one of the places where I think Sun really fell down. They defined everything in terms of Java EE, in terms of Java endpoints. And so when people outside of the Java world wanted to play, they realistically couldn't. Does it have to be HTTP? Again, no. I want a degree of interoperability, but truthfully, I only want as much interoperability as I need. So today, if I'm building an application, if it's for internal use and everybody inside the company is running a Windows box, cool, that's as much interoperability as I need. If tomorrow we start bringing Macs in, well then now I need to interoperate on both platforms there. The day after that, I have to start thinking about mobile. Okay, this is not an unreasonable scenario. I probably want to be thinking about interoperability pretty early. But the beautiful thing is that there are definitely ways that we can extend, we can create proxies and translators and adapters and whatnot to extend that communication backplane out. Or HTTP clearly embraces all technologies. That's one of its beauties. But HTTP, client-initiated request-response protocol, if what I need to do is some kind of server push, HTTP does not do that well. So consider something else for your communication backplane. What about SOA? What about coarse-grained services? What about microservices? Hey, sure, yes to all of it, right? When I'm talking about modern web, from one standpoint, what I am talking about is a service-oriented architecture. If you think about each API endpoint I'm building and you want to call that a service, booyah. You call it a piffle for all I care. The point is, you've defined this endpoint, and the scope of your space, your thing, can be as small or as large as you really want it to be. If I'm building an HR system, if I'm building an HR platform, yes, I need to be able to accept the idea that people are going to go on vacation. Does that also mean I need to be able to handle medical requests? Depends on the scope. Should these be microservices running inside my modern web architecture? Is the modern web itself a microservice? I don't care. I really don't. These are terms. It's really a question of scope. It's a question of sizing. It's a question of how much granularity do I want to have. We have this messaging and event system, right? There's a new architectural style that's emerging out of a lot of what's going on in the .NET world, CQRS, command query responsibility separation. And one of the things they choose to do is they choose to see things more as instead of storing data entities in a relational database, they will store events and event stores. And this is often on the other side of a messaging or event bus communication backplane. It all works as long as it's a standard communication backplane, as long as it has some well-recognized data entities and it can reach across to all the different clients that you care about. Whoops, skipped one. What about the cloud? It's a place where you host your modern web architecture. Any questions? Whether you want to host it locally or in the cloud, I don't care which. In some cases, the cloud will give you some benefits. They'll give you some tools to make things easier, right? Heroku and CloudBees and Cloud Foundry and so forth. They'll all give you some services to make it easier. Parse.com. They'll give you a user system right out of the box, so you don't have to build that yourself. that's great, just consume it. That's awesome. I don't want to worry about that stuff. Is it functional? Is it object-oriented? Is it RESTful? These are all approaches we take to structuring the code internally. Certainly, from the standpoint of if you're using HTTP as your backplane, then yes, there's going to be a certain amount of resource orientation you will want to take because that's part of the way HTTP was constructed. But you can look at a number of operations that we do on the web with very functional eyes, right? When you see Venkat come up here and talk about functional programming, a lot of the concepts that he's going to talk to you about, they're definitely going to lend yourself more towards some of this HTTP-based. You start looking at each verb and you say, wow, each of these could be their own separate function. And there's some value to that too. And then you start thinking about the data entities, the resources, our entities, et cetera, and you start realizing that there's a bunch of behaviors that are attached to those entities, and you start thinking around objects, and that all works too. There is no one driving language or approach that we want to use for all of these. In many cases, we want to grab all of them in the aggregate. One of the things that comes up as a part of the CQRS event store scenario is whether or not the data we're working with should be stateful or stateless. Do I want to be modifying state or not? Well, obviously, in a perfect world, you would never have to modify state because then we wouldn't have any concurrency issues whatsoever. Unfortunately, we don't live in that world. Things change on a regular basis. Whatever tools you use to help deal with modifying state, that's totally up to you, right? We can expose state even out of these supposedly stateless systems. We just have to structure it correctly. In an event store system, this is the state as it was prior to January 1 of 2015. This is the state after January 1, 2015 until April 17th, 2015. All of that is an event store approach. And then we've got all of those different clients, right? The mobile web, or the modern web architecture embraces mobile. A platform doesn't care what its clients look like. A platform doesn't care, in some cases, if it has clients. In many cases, its clients will be other systems, right? Because I am serving as the platform where my client is another platform over here and another platform over here. Perfectly acceptable. But frequently, we're going to want to build applications for the mobile space, and they will need to be able to communicate to these platforms. And the perfect idea here is that each client, whether they are internal or external, is treated exactly the same. There's a very deliberate wall set up between the clients and the platform's internals. This is how we drive encapsulation within this thing. In a lot of ways, a lot of this seems kind of redundant. We've kind of been doing a lot of these things already. We've been thinking about encapsulation for so many years, but in some cases we've been applying the encapsulation at the wrong points. If you ever built a data access object in Java, a DAO, and you ever created private fields and then you had public getters and setters, why? If the DAO's internals change, you're going to have to change the getters and setters. You're not really encapsulating anything at that point because the DAO itself, its job is built around the very data that it's trying to convey from point A to point B. Functional languages, we call those tuples, and they're just a built-in structure. They're just basically a class with public fields. And it's perfectly acceptable. In some cases, what we want to do is we want to start thinking about encapsulating at a higher level. We need to start thinking about encapsulating at the platform level. We define those data entities. Those are our contract in and out. The services guys, microservices, macro services, I don't care what you call them. They're thinking along those same terms. We need to encapsulate at the service level. We need to encapsulate at the platform level. Because inside the platform, everybody needs to know what's going on, period. Everybody, they're all working together. Suggesting that, for example, an iterator should be encapsulated from the collection it iterates across is kind of ludicrous. That's a case where they need to share details. The platform itself needs to know what's going on internally. But externally, clients should be very nicely kept away and versioned and secured and so on. What should that security context look like? That's kind of up to you, right? What should that data context look like? Does it have to be a relational database, or can it be one of the various NoSQLs? Again, that's up to you. The point is, the platform serves as your interaction with the rest of the world, and inside the platform, you do whatever you'd like. Some ways it's the same story warmed over, but in a lot of ways it's the same story refined after 25 years of working on this thing that we call the World Wide Web. The web itself is a modern web architecture. It's not the only one. You can certainly build your own MWA inside your company. As a matter of fact, there are several large firms, Google, Microsoft, etc. They've built their own internal internet, so to speak. They have their own web servers, their own sites. Amazon, same story. There are places you can browse inside the companies to see things. They've created their own web architectures internally. And some of them follow the same principles as the World Wide Web that gave birth to them, and some of them don't. And that's okay. In many cases, if you look at some of the various business architectures that people have put forward over the years, the way banks charge or cash checks, that is also, they follow some of, we kind of wish they would follow more of these principles, particularly around versioning. Excuse me. At the end of the day, it is my belief that starting from about 2013, 2014 going forward, what we're going to be building will not be web apps, web systems, web pages, but platforms. And the sooner that you come around to adopt the notion of a platform as your driving goal, as opposed to building just a specific web application, the sooner you'll be able to A, take advantage of a lot of the things you're seeing here, but B, have a little bit clearer idea in mind as to what it is exactly I'm trying to build, and what it is that I'm going to need to build so that other people can get what they need done without me having to go back and rebuild it on a regular basis. And that's it. I'm done. Peace out, y'all.